Hey everyone, welcome back. If you aren't seeing this after the math introduction, then welcome to a new school year. And if you are seeing it after the math introduction, then, well, still welcome to the new school year, because this is our first lesson for our science class. So we'll go through some of the same housekeeping items that you'll see in the math introduction, just in case you're watching this one first. And then we'll dive into a little bit of a breakdown of the different topics that we'll be covering this year, and sort of my reasoning for why we're going to go about it that way. So here's an overview of what you can expect to see over the coming year. So each week we'll see about one video released per class. So for our math class, because we're scheduled to have a couple more classes in the week, there might be 2 videos or they might be a little bit longer. But since we've only got one science class a week, and I think it's, what, 45 minutes long? Correct me if I'm wrong, but I think it's 45 minutes long, or at least the last time I checked, that's how the schedule was looking. So based on that, chances are most topics you'll see one video per week. There might be some topics that are a little bit more complicated or require a little bit more discussion, or I want to show you like a website that you could visit to understand the concept better, things like that. And those would be videos that are done in 2 separate parts. So that's certainly something that we might see here and there throughout the school year. And just as I said this for math, it'll be the same thing here, that there might be some weeks where by design I've chosen not to upload a lesson, and that's a lot easier to do for science if we've only got one class in the week. Maybe if it's a studied period that I know I've assigned a test that you guys have due, or I just assigned you a test at the end of the previous week, and maybe I've also assigned you a math test or something like that, that if I know that in my classes you've got a lot going on, or if I hear from one of the other teachers that there's a lot going on, then there might be the occasional week where I choose not to post a lesson for you guys, just so you have more time to get your other work done. And then there might be some weeks where I'm just not able to because I'm swamped with my own work, because I'm taking 5 classes, I'm teaching these 2 classes, I'm teaching another class independently of this, and I'm doing some other work outside of that as well. So there might be the occasional week where I'm a little swamped and don't have time to post a lesson. Those should hopefully be fairly rare, as I'm going to try to record the lessons early on in the week and whenever I get spare time throughout the week. So I'm hoping I'll be able to stay at least on schedule, if not ahead of schedule. All the videos will be posted on this channel where you're watching right now, so you guys are all well acquainted with this channel after having seen these videos over the past couple years. Well, I'm recording this video just a couple of hours after the math intro, so I'm still not sure. I don't have any update on assignments and tests, whether they'll be posted through like a Google Classroom kind of setup, or something else, perhaps through the website that I've created, which you can take a look at that video as well. The link to the website will be in the description. But anyway, so right now I'm not positive of what exactly we'll do for assignments and tests. Maybe the idea I've kind of got in my head right now is, if we're not using Google Classroom, then I can post the assignment or the test on the YouTube channel, or not on the YouTube channel, on the website, and maybe I can post a little brief sort of any clarifications for the test or assignment on the YouTube channel, and just leave it there a week or 2 ahead of the due date, and you write it when you want and email me your results. So something like that. That might be an option of something that we could do to deal with assignments and tests. But the first assignment and or test are both a couple of weeks away at least. First assignment is a couple of weeks away, and first test is probably a month or maybe more than a month away from where we are right now. So we've got time to figure those things out, and once I have a better idea of how that's going to work, then I will give you guys an update. So I'll talk to your other teachers and we'll see what seems like the best plan of action there. And once again, I said this for the math lessons, but it'll be important in our science classes as well. If you do need to rewatch a lesson, or perhaps you missed a class, so you didn't get to watch it in class with everybody else, and you want to get caught up before the next day, then just look up Esperanza online in the YouTube search bar, look for this new logo. I'm including this here just because the logo for the channel is different, so I don't want you to get confused that that maybe this isn't the same channel. So that's the new logo for the channel. That's what it looks like, and that's what you'll be looking out for if you need to look up any of the videos from this year. And as well, if you feel like watching any lessons ahead of time, that's totally an option that's open to you as well. So that could be if you want to watch a lesson that you see I've posted it in the evening, or I've posted it on the weekend or something like that, which will probably be the kind of time that I uploaded it. Or you want to rewatch a lesson in the evening or on the weekend, then you can find the channel that way as well. For some of these topics, especially in the topics that I know more about, we can get into some of the more complicated aspects of how things work. Not like with math necessarily, but just exploring the concepts as ideas and talking about them. It can still get complicated and a little bit hard to swallow at some point. So hard to digest those topics. So in those cases, I recommend that you rewatch the lessons and let me know if you have any questions. Try to take notes, as detailed notes as you can in class, and that's kind of an advantage to having the videos online, is if you feel like you missed something, you can always pause and go back or rewatch the video later when you're by yourself, things like that. And that you can also rewatch all the videos before a test or before an exam, something like that. So there are some advantages to the online system. The downside, of course, is I don't get to see the looks of confusion on your faces when I'm explaining something, so it's a little hard to gauge sometimes if whether what I'm saying is going over your heads or not. But if there is a problem like that, and you feel like you're not really understanding something that I said, and you rewatch it and it's just not making sense, let me know, and I'll see if I can post a clarification somewhere, either on YouTube or on Instagram or on the website, or something like that. Maybe I can answer your question if you post it as a comment. I can just answer right there. If it's something more in depth or something that that just a lot of you are struggling with, I can post a whole separate video to clarify that. So do keep in touch with me if things aren't making sense, and I will work on fixing those problems as they come up. So I think that's kind of a wrap on all the housekeeping kind of items, things that aren't related to the actual topics of study. So here are the actual topics of study. So we'll be focusing on 5 main branches of science. So we'll look at astronomy, then we'll look at geology, then we'll move on to biology, chemistry, and finally physics. So I'll explain my rationale for these 5 and the order in which we're going to go. The order is as you see it there. So we'll start with astronomy and we'll end with physics, and we'll go in order from first to last. The emphasis will be on astronomy and physics, as these are my personal areas of expertise, so I could dedicate entire lessons to relatively small chunks of the astronomy unit and the physics unit, whereas because I don't know as much about biology and chemistry, I can't talk for quite as long about those topics. So you might not get as in-depth of an explanation about how things work. So in that way, if I'm not able to go as in-depth just because it's not my specialty, then we'll be able to cover each topic a little bit faster. So we might wrap up the chemistry unit in 5 videos or so, maybe a couple of videos on the periodic table, a couple of videos on bonding, a video on balancing equations or something like that, and that's it. And we could stop right there for the chemistry unit. But for astronomy, I can really take you piece by piece. We could do a lesson on galaxies, a lesson on stars, a lesson on these planets or those planets or other things in the solar system and how they all work together. What is dark matter? What is dark energy? All of these different concepts that come up in astronomy, because those are the things that I focus on. So you can expect the astronomy and physics units to be the two longest ones, and geology, biology, and chemistry to be a bit shorter in between. So let's take a look at some of the topics that we'll study in each of these branches. So in our astronomy unit, we will begin with an introduction to scientific notation. And this is actually something that you might see in our math class before you get around to it in our science class, just because of how the schedule is set up. So basically, we'll talk about why scientific notation is useful and why it's useful particularly in astronomy. For those of you that haven't seen it before, what scientific notation allows us to do is it allows us to take a number that looks like this and write it like this. And so we can do this a lot in astronomy. Basically, the idea is, the really simple idea is, if you have a number that ends with a whole bunch of zeros, so like in this case we've got 9 zeros, then you can write that as a 10 with a little 9 in the exponent. So we'll talk about this more in detail when we actually do our lesson on scientific notation. But the reason this comes up so much in astronomy is that we tend to use a lot of really big numbers in astronomy when just trying to describe things. If you're trying to talk about how much does the sun weigh, what is the sun's mass, you're dealing with a number that's like 31 digits long. So you can condense that down using this kind of notation, so that you could write it as a 10 with a 30 in the exponent, instead of having to write out the whole number start to finish. So things like that. If you're talking about the mass of a really big object like a star, or even a planet like Earth or like Jupiter, it doesn't even have to be a big planet. Earth's not by any stretch of the imagination among the bigger planets in our solar system, but writing out the Earth's mass in kilograms is still a really long number. So if you're talking about the size of objects in space, if you're talking about the radius maybe of an object in space, the distance from the center to the surface, that's usually not as big of a number, so we usually won't need scientific notation for that. But again, it depends on the object. Maybe for a star you would prefer to use it, and for a planet you would not. If you're talking about the distance between galaxies, if you're talking about the size of a galaxy, all these different quantities come up where you're dealing with huge numbers like billions and trillions and quadrillions, like enormous numbers, and it can go a lot higher as well. So it's not common for it to go much higher than like maybe quintillions or so, which is still a lot of zeros. But so basically we'll start with an introduction to scientific notation, just so that if I want to introduce some numbers in any of our lessons to talk about the size of something, or how much it weighs, or how far away it is, then you can understand it using scientific notation. So we'll start there. And then after that, we'll try and get a sense of our place in the universe. So we could take this from sort of like trying to map out the universe and trying to figure out where we are. We can take that kind of an approach to it. That might be neat if we can find some neat resources for that. But mostly I want to try to give you a sense of scale for how small Earth is compared to everything that's out there. If you look out into the sky at night, on a clear night, there's a lot of stuff that you'll see, and I want to try to give you a sense of what is it that you're seeing, why does it look the way it does, how big are those things, how far away are those things, are they all stars, are they all planets, what's with the the band that goes across the sky at night. Um, all those things I want to bring to your attention when we're trying to get a feel for where we are in the universe, how small we are, things like that. Um, After that, we can talk kind of in general about some of the largest structures in the universe. There are bigger ones, which are basically clusters of galaxies, but we'll talk just about individual galaxies themselves. And we'll take a look at our galaxy and how big it is and how many stars are in it, and what's our solar system's neighborhood like? What stars live nearby? Do they have planets around them? Uh, are they moving towards us? Are they moving away from us? Things like that. What's at the center of our galaxy? All those things, all those kinds of questions we'll address when we look at our galaxies section of the astronomy unit. And then after that, we'll look at stars. And star formation is not necessarily people's favorite thing about stars. I think it's still fascinating the way stars form and how stars today are in some ways different from stars at the beginning of the universe, just because of the different elements that are available to them when they're forming. Um, so we'll talk about the different kinds of stars. We'll talk about the really small stars and the really big stars, the dim ones, the bright ones. Where does our sun fit into uh, this picture of this is what stars can be from this small to this big? Where does our sun fit in? This cold to this hot, where does our sun fit in? We'll try to give some context to where our sun, where our solar system sit in this sea of stars, even just looking within our own galaxy. And then we can talk about everybody's favorite part of astronomy, which is what happens when stars die. Because when a star dies, it becomes one of three things, and that's these three things right here. So people's least favorite is the white dwarf, which is what our sun is most likely going to do when it reaches the end of its life, is it will turn into a white dwarf. So it's not people's favorite thing. It's not necessarily going to show up in the news as much as the other two options, but it's definitely worth studying as it's reasonably common. And then we'll talk about the two more exciting options for what happens when a star dies, which is that it could turn into a neutron star or it could turn into a black hole. And we'll talk about what makes black holes so weird and where's the closest one and are they dangerous and what happens if you get too close to one and what happens if you go inside one. Do black holes die? Do black holes get bigger? Are black holes hot? We can talk about these kinds of questions when we're talking about what happens when stars die. So lots of fascinating stuff in this section. And then we can zoom in. We start out by talking about our place in the universe, and then we hone in on our galaxy. We hone in from there to our solar system. So we can talk about the different things in our solar system, all the sort of the stars of the show, so that would be the inner planets and the outer planets, which is what everybody hears about. And then we can talk about the dwarf planets, which have caused significant outrage in the past 15 years with the whole Pluto fiasco. We'll talk about dwarf planets. I will explain to you my views on whether Pluto should be considered a planet or not, and I will explain to you why I think the way I do about it. You don't have to agree or anything. I'm not going to ask you on the test, is Pluto a planet? Yes or no, and state why. You guys are entitled to think the way you want to think. I just want to give you my reasoning for whether it is or is not. And on top of that, we'll talk about other dwarf planets that most people tend to not hear about. We'll talk about the asteroid belt and the Kuiper belt, which also people tend to hear about the asteroid belt, but not as much about the Kuiper belt. So we'll talk about those two as well. And we'll talk about the Oort cloud, which is this region of icy comets way out in the outermost part of our solar system. And basically the edge of our solar system would be where the Oort cloud is. So we'll get a good understanding for this is what our solar system, this is the stuff it contains, all of that good stuff. Then we'll look at Earth and the Goldilocks zone, which might be a term that you've heard before. If not, you'll end up seeing why we call it that, because it makes a lot of sense in the context of Goldilocks. But we'll basically be looking at what makes Earth special compared to the other planets. What makes Earth different and so um, fine-tuned for life, I guess, might be a good way to put it, is what makes Earth um, basically what makes Earth unique. What does Earth have that the other planets in our solar system don't have? Why do we have billions of species here, and as far as we can tell, none of the other planets have any? And we'll look at, is Earth the only planet that we've seen that's got these properties? We'll take a look at exoplanets, which are planets that go that orbit other stars. So planets like Earth, or like Jupiter, or maybe like something else, um, but that orbit stars that are not our sun. So far away from us and orbiting a different star entirely. So we can take a look at those planets and are they similar to Earth? Are scientists expecting to find signs of life on this planet or this planet or this planet, and why or why not? So we can take a look at those kinds of topics. And then we can also look at cosmology towards the end of the astronomy unit. We'll take a look at sort of the history of the universe, going back to the beginning of the universe, which at this point is estimated to be 13.8 billion years ago. This billion with a B. So we're talking about a long time ago. We'll talk about the age of the universe, and we'll throw in the age of the galaxy and the sun and the earth in there as well. And we'll take a look at dark matter and dark energy, which have been sort of some of the the big hitters in astronomy news over the past few years. Have been things related to hunting for dark matter and dark energy. But yeah, so we can talk about these different ideas in our astronomy unit, which is our first unit. So you'll see all of these in the weeks to come. Then we'll move on to our geology unit, where we will take a look at a few different things. It's a fairly short unit just because originally I was thinking we would go from astronomy straight into biology, but then I thought maybe we can squeeze in a bit of a small-ish geology unit, so sort of like a geology mini unit in here in the middle. So in our geology unit, we'll begin by looking at rocks and minerals, and we'll look at the hardness scale that we use for minerals. Then we'll focus our attention on different processes that shape the Earth's surface. So we'll look at earthquakes and volcanoes primarily, and the scales that we use to, classify how powerful they are and how dangerous they are. And then we'll get a sense of Earth's history. So, in our astronomy unit, we started out with this is the universe, this is the stuff in the universe, this is how old it is, this is what its future might look like. And then we'll sort of zero in on Earth and look at the kind of the same ideas, but on the scale of a planet instead of on the scale of the universe. So we'll look at, what are the things that make up Earth's surface, the rocks and the minerals, what causes those things to change or be recycled, or new things to be created or old things to be destroyed. So we'll be looking at things like volcanism, and maybe we can squeeze in a little discussion on plate tectonics, but we did that last year, so I won't focus too much on it. But I might revisit that, so we'll see. And then we'll look at geologic time. So in our astronomy unit, we looked at the history of the universe, basically, and then here we'll look at the history of Earth from start to the present. We'll look at some of the extinctions that have taken place. We'll look at some of the organisms that have lived on this planet before us, like the dinosaurs, things like that. And then if we have time, if we've got room for an extra lesson to squeeze in to our geology mini unit, then we'll talk about how geology impacts us sort of in our daily lives, and we can maybe take a look at a couple of regions of the world that are especially affected by geologic processes, things like that. So that's sort of the rough idea for our geology unit. We might have to, you know, make it smaller if it turns out there's not enough time to go through geology properly. Then we might have to get rid of small sections here and there. But it's a it's a mini unit on geology anyway. So that's sort of the idea, is that we started with a look at the universe, and then we take this brief look at Earth, which sets the stage for us to move on to our biology unit. So our biology unit is going to be all about DNA. Now, I know this doesn't look like very much because it's just 1 point and then 4 subpoints, but these 4 subpoints will take a while to go through and explain, and they're very, very interesting. So hopefully you guys enjoy what you learn about these topics. I personally really enjoyed studying this when I was in high school, but that being said, it was when I was in high school, and five, that's more than 5 years ago now. So I will uh, be covering this as best I can, but because I haven't taken a single biology class in the last 5 years, um, my knowledge of biology is nowhere near my astronomy, physics, or even my geology. Um, but basically, the idea here is, in years gone by, we've talked about cells, we've talked about the kingdoms of living things, we've talked about biomes and ecosystems, and I want to take a look at DNA. What makes the life on our planet special? Why do so many organisms exist on this planet, and they all have this structure for, replicating their genetic code? What are genes? What causes, people to look similar to their parents, or like a mix of their parents' appearance? Um, what is DNA made of? What happens if there's a mutation? How does DNA replicate itself? How does it make copies of itself when you're generating new cells, or when you're, you know, generating a new body, when when you've got a fetus developing, things like that. So we'll take a look at the nitty-gritty details of DNA. What's it made of? What does it look like? What happens when things go wrong? How frequently do things go wrong? What are genes, and how can we use what we know to sort of make predictions about what to expect if you tried to create a new offspring from two parents? What kind of features would you expect to see? And we'll look at these kinds of things in our biology unit. It's not going to be the longest unit because, once again, my biology knowledge is nowhere near my astronomy, physics, and geology. So I'm going to try to play to my personal strengths and focus on the topics where I have the most knowledge, the most that I can share. But yeah, so the idea now, just to sort of put it into context, is we start with the universe as a whole, then we zoom into Earth, and then we zoom into the stuff that makes life life. So basically, we'll go from Earth, the stage being set in geology, that we're looking at Earth and what makes it special, and then we zoom into the stuff of life, DNA, and what makes it the powerful molecule that it is. And what we'll find when we zoom into the structure of DNA is that we'll be getting into the territory of chemistry, because when you take biology and you zoom in, you'll find that a lot of the processes are just the rules of chemistry being applied in an organism. So we'll take a look at the building blocks of chemistry. We'll look at atoms, we'll look at the periodic table, we'll look at how atoms can bond together to form molecules, and the different types of bonds that you can get. And we'll look at how you can take molecules of one type and then run them through a process that spits out molecules of a different type. And that's what we'll get to when we look at balancing equations down here at the end of it. So we'll start off with understanding the periodic table. We'll take a look at atoms, we'll take a look at some of the interesting ones, see if we can notice any patterns in the structures of the atoms and what they look like. Not what they, actually look like in reality, but the way we draw them. And we'll look at how to draw them. I'll teach you how to go through the process of drawing atoms, and and how you can understand the way that atoms interact with one another based on the way their diagrams look. And so that's what we'll explore when we look at molecules. And then finally, like I said, we'll look at balancing equations, where basically you take atoms of one kind and then turn them into atoms of, you take molecules of one kind and then you turn them into molecules of a different kind, but using the same basic atoms in that equation. So we'll explore all of this in our chemistry unit. And then in the spirit of zooming in, you'll see next that our physics unit goes even smaller. So here's the setup for our physics unit. Now, a lot of people, when they think of physics, they don't necessarily think of atoms. Atoms tends to be more of a chemistry kind of subject. People might think of things like Isaac Newton and his laws of motion, or they might think of electricity, or they might think of magnets, things like that. They might think of things like quantum mechanics, but not really understand what that means, or they might understand everything about what it means, depends on the person. But basically, we'll keep with our spirit of zooming in. So we're starting with astronomy, we're looking at the universe as a whole. Then geology, we're looking at just Earth. Then biology, we're looking at just DNA. And then chemistry, where we're looking at the stuff that makes up DNA at a fundamental level, which is atoms. And then in physics, we'll look at subatomic particles, so things that make up atoms. And we'll look at the sort of the physics version of the periodic table, which is the collection of the things that make up everything that we see in the universe, which is kind of what the periodic table looks like it's supposed to serve, the periodic table in chemistry. But then this one is even more basic in the sense that, like, it's even more fundamental. And what that means is that, like, the things in the physics version of the periodic table, which is this thing called the standard model, the things that show up in the physics version of the periodic table make up the things that we see in the actual periodic table. So these will be the things that make up atoms, and these will be the things that dictate how atoms behave with each other and how these different particles behave with each other. So there's not going to be any math here because the math itself is tremendously complicated, but we'll explore the ideas of what scientists currently think our universe looks like at the smallest of scales, and we'll look at the different forces that the universe has within it, and there are four right now that we know of, four fundamental interactions, as we call them. We'll look at what they are, and we'll see how they fit into the standard model and things like that. And then once we've gotten there, that's almost as small as we can hope to get. So beyond that, we'll zoom back out. We'll take a look at physics on a macroscopic scale. So what I mean by that is it's not microscopic. That's not a typo. Macroscopic means that, like, it's on the scale of things that we can see. Microscopic is things that are too small for us to see. Macroscopic is on the scale of things that we can see and bigger. So that'll be things like, we'll take a look at Newton's laws. We'll take a look at classical physics, as we call it, which is like the physics of everyday life. If you throw a ball, what happens to it? Things like that. We'll look at sort of that side of physics. And that's where we might see some of the math that we study in our quadratics unit. And we'll take a look at rockets and what makes it so hard to get rockets out into space, and what things do we need to consider when we're trying to bring a rocket back down to Earth, things like that. So we'll look at that side of physics on the scale of our daily lives. And then after that, we'll take a look at physics on the biggest of scales. We'll take a look at physics in terms of the physics of the universe. We'll look at the physics of how planets orbit stars, and we'll look at the physics of stars themselves. What keeps them from collapsing in on themselves? Why are they hot? Where does the energy that they produce or that they release, where does it actually come from? We'll look at the physics of black holes, because there's some really weird stuff that goes on with black holes, and I hope that we're able to get to the physics unit before we run out of time for topics like that. And then I'll introduce you to just a couple of sort of unsolved problems in physics. The big one being that physicists are trying to create one ultimate theory that explains everything. And right now that's not happening. We're at a crossroads that there are two leading theories in physics, one which talks about the really, really big things in space, and one which talks about the really, really small things. And those two theories don't work well together. They don't like each other. So we'll talk about that problem and why it's a problem and maybe a way to fix it, possibly, hint, hint. So in case any of you are interested in going into physics, which I'm not trying to push you to do that, but physics is pretty awesome. So we'll take a look at sort of where physics stands today after we look at all these other topics, and that'll round out the school year. So that's basically the idea. So to sum up, just so you can have a look here. So we'll start with a look at our place in the universe. That's up here. We'll take a look at our place in the universe. We'll look at galaxies and stars and, what makes our planet special. Is there anything that makes our star special? Is there anything that makes our galaxy special? Things like that. What's in the neighborhood of our sun? What's in the neighborhood of our galaxy? We'll answer those kinds of questions here in our astronomy unit. Then we move on to what makes Earth special and what processes shape the Earth into the world that we see. That's our geology unit. Then we zoom into the stuff of life. We'll look at DNA and what makes DNA the molecule that it is, and that's in our biology unit. Then we zoom in even farther to chemistry, where we will take a look at the things that make up everything, quote unquote, because that's what you may have heard the joke about why you should never trust an atom, because they make up everything. So we'll look at that in our chemistry unit, the stuff that makes everything else up in the universe. And then we'll look at how that's not actually true, because atoms themselves are made up of even smaller things. And we'll look at those most basic ingredients of matter and the rules that they obey. So basically, if the universe was a game, these things would be the pieces, and the forces of nature would be the rules of the game, if you will. So it's like having the different particles or the pieces, and then the forces like gravity or like electromagnetism. Those would be the rules of the game, that these pieces have to follow these rules. And then from there, we zoom back out. We'll look at the rules of physics in the world that we can see, and then we'll go back to a cosmic kind of view where we look at how physics acts on the biggest of scales. So you can see that we go from here, we zoom in, zoom in, zoom in, zoom in, and then zoom back out to where we start. So that's the plan that I've got for you guys for our science class this year. I hope you're as excited about it as I am. And if you have any questions, get in touch with me in any way that you possibly can, and I will try to help you out as best as possible. But if there are no questions, then I will see you all in the next video. Have a good one.